Welcome to the online video tutorial series of computer network subject. In this video, I will explain the last layer of OSI model, application layer. I am Jishan Singh, Assistant Professor in IT/ICT Department of LJ Institute of Engineering and Technology. So when we are talking about the application layer, we already know the OSI and TCP/IP model. This layer is working at the top of both the layer, OSI and TCP/IP. So in this video, I will cover how the application layer is working. What are the basic functionality is providing by application layer? What are the mechanism is working behind the application layer procedures, and basic introduction of web and HTTP. So let's understand basic outline which will be covered in this unit. So when we are talking about the application layer, so in this video I will cover what are the principles behind that our application layer is working. Then the brief introduction of web and HTTP, how the HTTP protocol is working, how the request and response message format for HTTP is given. Then after, I will cover the basic concept of cookies and proxy server that will be used by our real-time web and HTTP protocol. And the last, the protocols which will be used by our application layer, that is all about FTP, that is file transfer protocol. Then the concept of electronics mail that we are using during the internet, that is email, and SMTP protocol, how the SMTP is configured and what are the basic steps to use the SMTP. Then POP3 and IMAP protocol is used for configuration of email, and the last DNS. So let's start with today's topic with the principle of network applications. So when we are talking about basic idea how the packets are transferring from source to destination, in each and every layer we understand this scenario with this context. So number of hosts are given here, number of devices are already given here. So how the exactly application layer is working here? When we are talking about the data link layer, then we are talking about the MAC address. So each and every device contains MAC address. When we are talking about the network layer, the network layer must be implemented on all that particular routes from where our data is transferring. But how the application layer is configured? So application is required at sender and receiver side only. Intermediate layer doesn't require application layer, because between the intermediate layers, intermediate particular nodes, only data is transferred. Only source and destination is requiring the upper layer, that is the viewable view, that is the application layer. So when we are talking about this, it runs on the end system only, that is your source and destination. We have to communicate over the networks, and that network is providing some services, base of services, that is web server software communication with the help of browsers. So we doesn't require to write software at the core devices. Core devices all about the how our data will transfer. That may be your routers, that may be your hub switch or intermediate browser. That doesn't require to implement our application layer. So when we are talking about the application layer protocol, then it sends the message from source to destination via top to bottom at the sender side, and the receiver side it is about the bottom to top. Now we are talking about the applications which are being provided by our application layer. So in real time we are daily uses, we are using the number of applications. That may be email services, that might be our web access services. Then when we are talking about the text messaging, then we are using the remote login, then P2P file sharing, then we are using the streaming of videos online, then we are talking about the voice over IP, real-time video conferencing. So all applications are the real-time example of our applications layer. So application layer directly or indirectly implement these type of services. So how exactly our application is architected here? So in the previous slide, I already discussed number of applications. So either that applications are client server or peer-to-peer architecture contains. So what are the architectures are created by application that follows client side architecture or peer-to-peer architectures? So let's understand both the architecture one by one. First one is your client server architecture. So when we are talking about the client server architecture, source to destination our data is moving. In between we have a number of nodes, but one particular source is known as a client, and at the second side what the machine is available, that is known as a server. So it is always on. That is the case of server. If server is not available, the client request is not fulfilled. So server having one permanent IP address from which it is talk with the number of machines, and our client can respond request to particular server. Now what about the clients? So client is communicate with the server. When the client is required some data item, it requested to the server with the help of that particular IP address. So logically, if we are talking about the communication between clients and server that requires some basic addresses, that addresses is provided by the lower level our addresses. Now we are talking about the P2P architecture. So what is P2P architecture here? So when we are talking about the client server, always one server is in the central side, number of clients are requested to each other. But when we are talking about P2P architecture, according to this figure, we can say that number of particular hosts are directly connected with each other. So we are not saying that each and every server and each and every client is directly connected, but each and every machines behave like a client and server both. So here what happened in client server? Server is providing the functionality. Client is not providing the functionality. It can only request. But when we are talking about the P2P architecture, there is no requirement of central server. Our arbitrary systems are directly communicating with each other. They are independent from each other, but the terminologies, the architectures are complex as compared to client server architecture. So how now particular host, our client server are communicated with each other? For that we have to understand process communication. So when we are talking about the process communication, first we already discussed about the client and server terminology. Client is processing, initiating, that is our client process. When the server is responding, they are waiting condition, that is all about the server processes. But this process is within the number of hosts here. So how they are communicating with each other? They are divided into the two parts. First is all about the inter-process communication, that process within your operating system. When two hosts are sharing that type of operating system, then they are known as an inter-process communication. But when we are talking about the different host communication, then we are understanding that terminologies are known as a exchanging processes, exchanging messages between that number of hosts. So this is the basic process communication, how they are communicated. But exactly from where our data is passing. So for that we have to understand the concept of socket. So when we are talking about the socket, then it is one endpoint of our system. From that endpoint, our client request is going outside, and our server request is coming inside. So from that endpoint, always our request come in and come out. So socket terminology is used at both the end when our data is communicating. But where the socket is implemented, we know after application our transport layer is available. So socket implementation is all about where at our transport layer properties. So at the border side of our application layer, in between application and our transport, at the endpoint our socket is available. So socket is available that provides the endpoint for our each and every request for come inside and go outside. Now what are the address processing is available? So we know already transport layer and network layer is useful for communicating over the network. So what is the role of our IP address here? So IP address is providing the unique identity to each and every machine. So what is the role of our transport layer here? The transport layer is providing one port number. So using IP and port number, we can communicate point to point here. When we are talking about only network layer address, it provides only the end-to-end communication. But within the process, from source to destination, if we want to communicate with the help of application layer, we require both these things, that is our IP address, that is our logical address provided by network layer, and the port number, that is the, also we can say that it is a part of our socket, that is the provided by the transport layer. So when we are talking about the addressing used by our application layer, it uses both network layer IP and port number from our transport layer. So what are the other transport layer services are used by our application layer? So the basic services that are provided by the transport layer, first one is our data integrity, next one is timing, that relays on the delay, because when we are talking about telephonic services, video conferencing services, we also depend on that. Then we are talking about the throughput, how the data is communicating, how faster data is downloaded, that's why we also dependent on that. And next one is very important, that is security. So our application layer is totally depend the services provided by our transport layer. Now we are moving to the second type, that is all about the web and HTTP. So first question is all about what is web, how we are talking about the application layer is use our web concept. So web is nothing but the collection of number of pages, that is known as a objects here. So that object can be our HTML file, our video, our image, our applet, our audio file, anything. But over the network, if we store that type of object, if we are accessing those objects, so for accessing that objects, we require one platform. That platform is provided by our web. And the mechanism behind that accessing those objects, that is our HTTP. So the HTTP and web always come together. Without the combination of web and HTTP, we cannot access those type of data. So let's understand this example of our web. So how we can access the web? For that, in real time, we are using the URL. URL stands for our Universal Resource Locator. So using that URL, we can access those objects here. So our URL will be divided into the two parts. One is host name. So exactly who are the host of that host name is first, and then after our path name. Path name is telling where the exact our object is located. So for example, my object is my GIF file. So GIF file name abc.gif, but that GIF file is available at which place? That place is our host name. So when we are talking about the web is nothing but one type of specific address where his user is requested for that object. Now how we are accessing in the background, for that we are trying to understand next protocol, that is our HTTP Hypertext Transfer Protocol. So we always know about the how exactly our HTTP protocol is working, what are the mechanism is behind that. So when we are talking about the HTTP protocol, simply we are browsing something from our laptop, mobile, computer, and at the receiver side, that server is giving the response. That is the whole scenario is known as our HTTP scenario. So it is not fixed one device. If we are using machine, then HTTP request is generated by our browser. Then if request is received at the server, if server is available and the requested data is available, then HTTP response is given. If it is requested by our PC or our mobile phone, from everywhere, if we are using the browser and our URL bar is providing this type of facility, we can say that HTTP request and response is giving this type of answers. Now, how exactly our HTTP is using this TCP concept? So we already know that in TCP, the TCP is providing connection-oriented packets. So if our data is reliably received at the receiver side, then we can say that we are using the concept of TCP. So our application layer is using the concept of TCP here. So the header field is using this type of concept, and they are exchanging the message between source to destination. But our HTTP protocol is stateless protocols. So what is the stateless protocol? So when we are moving from one page to another page, then it is not remember what the exactly in the background or what is the history of previous page. That's why we can say that HTTP is a stateless protocol. protocol. That's why server has to maintain all the information of the past. So at the client side, we are using the browser. But browser HTTP protocol is not maintaining this type of states. That's why at the receiver side, at which server we are communicating, server is responsible to maintain those information what the client is performing. So we have to remember that always the server is responsible for maintaining states. Now we are talking about the two important parameters of our HTTP connection. That is non-persistent HTTP and persistent HTTP. So when we are talking about the non-persistent HTTP, at most one object sent over the TCP connection, only one at a time. Then the connection is automatically closed. If we want to request another one, then the request is then our request is new created. But when we are talking about the persistent HTTP, it is not performed. Every time our request is not generated, when we want to close the connection, then we have to passively perform that. So if we want to downloading the multiple files, this protocol non-persistent HTTP is not useful. So how non-persistent HTTP is performing the task, let's understand. Suppose user is entering this URL www.xyz.com and then after one specific path. That path contains number of 10 images. Now I want to download 10 images. How the particular non-persistent HTTP is working? So in the first step, what happened? HTTP client initiate TCP connection to HTTP server and the process is beginning. Now in the next part, what happened? HTTP server at the host is waiting for that connection and accept that request. So connection is establishing. So this is the first step of our HTTP TCP protocol connection establishment. Now what happened? At the internet step, HTTP client send a HTTP request message. So for what we are requesting, we want to download some images at that particular path. In the response, HTTP server receive the request, that process and give the response in the form of that particular IP and port number that is created by our socket. So this is the basic step of our TCP connection, what we are learning in the previous chapter. So the same concept will be used by our HTTP here, because HTTP is using which concept? TCP concept. Okay. Now next step, what happened here? Now we can say that HTTP server closed the TCP connection. What happened? In the first three steps, only one object is given in the response. But when we are using the non-persistent HTTP, every time our connection is closed. So for each and every request, new request is generated. We have to generate. So according to this, step number 4, our connection is closed. So HTTP client receives the response message that contains the HTML file that display on the file, but only one image is downloaded. So for each and every item, data item we want to download, we have to repeat step number 1 to 5 here. So this is the case of how the particular non-persistent HTTP is following the steps. So what are the time taken by non-persistent HTTP response message? So let's understand with the help of this image. First is initiating the TCP where our data request for connection establishment. For that, some processing time is given, that is our RTT time, that is response time here. Then what happened? Our request is generated after receiving the acknowledgement of successful connection. Our request is generated for particular data item. For that time, our server is taking some time, and for that, some time is also consumed here. That's why RTT is also generated here, and the file is downloaded. So what happened here? For each and every data item response, we have to understand that for each and every data item, we are taking how much time? Response time. That is process. That is the weighted at the our sender side. So at the non-persistent HTTP response time, final non-persistent HTTP response time will be 2 RTT plus file transmission time. So at the end, we can say that non-persistent HTTP is taking 2 RTP plus 5 transmission time. So it is a too much time taken by for each and every request. So when we are talking about the persistent, how it will give the response. So when we are talking about the particular persistent HTTP, it is the answer of our, or it recovers the disadvantage of our non-persistent HTTP. So when we are talking about the persistent HTTP, it takes lesser time. Minimum 60 to 70% time is reduced by our persistent HTTP. Different HTTP versions are introduced by our today. So as by default, HTTP 1.1 version is providing persistent HTTP. So the time which are consumed by our non-persistent, that will be totally removed. Now we are moving to the HTTP message format. So HTTP is generally used two types of message format, that is a request and response. So this is the message format is given how our data will be look like in the header part of HTTP. From that we can know each and every things about our message. So basically mainly we have used three types of get, post, head type of message when we are sending the data. So get and post method is basically used here. So that is the first part here, get. So get is all about the request line. Okay, request line, header line, and our data. That will be basically three part of our request message. So request line is telling about how which method type is used. So method type is our get. Then after slash we are seeing that index.html. So index.html is our server file name for which we are requesting. Then after you can see that it is a HTTP slash 1.1. So here we are telling that we are using the HTTP protocol and the version of that HTTP protocol is 1.1. So using the request line, we are telling that we are using the message type get. My requested file name is index.html. I am using the HTTP protocol of 1.1 version. Next is all about host, from where we are requested. User agent. User agent is all about which web browser we are using, which type of text we are accepting, which type of language we can use, what are the encoding techniques are used by our particular, which are the characters that is accepted by my browser. That is all the methods are telling by our requested browser. And last one is keep alive. Keep alive is all about our persistent HTTP. If we are talking about non-persistent, that keep alive is not available. Okay, so connection keep alive, both that particular line is telling that we are using which version? Persistent version. In the last, that is our carriage return characters, that is the ending of our particular message. So when we are talking about the HTTP request message, we must remember that will be divided into the three parts: request line, header lines, then data. Data and particular message lines is divided by space, that will be enter. Okay, so our request line will be divided into three parts: our method type, that is get, then file name and HTTP version, then remaining particular all this stuff is part of our header line. Then our data part will be a last part, but between the header part, header line and data part, we are putting one blank line. So this is the HTTP request message. So basically I already told the get method is a type of message. So which are the another methods used by HTTP? So till HTTP 1.0 we are using get, post and head method. Where HTTP 1.1 version is used get, post, head, put, delete, number of type of message type. So when we are requesting, we are using the get. When we are getting the data, retrying the data, we are using the post method. We are using the head method. Then some information is putting inside the head information. Then we want to use put method. Then if we want to upload some data, we are using that data in the part of put. And if you want to delete specific task, then we are using the delete method. So this method is always written in our request line. Okay. Now we are moving to the HTTP response message. So when we are talking about the response message, it is divided into the three parts: status line, header line, and data part. So when we are talking about the status line, it first telling the version of HTTP. So here HTTP version is HTTP, then the version name is 1.1 and then 200 and OK. So that is all about the status. What are the status of my request? That is telling by our status line. So 200 OK is all about the successful receiving that particular message line. Then another types all are the part of header lines. That will be your date, which server is used, where this particular web page is updated, which are the messages are, which type of encoding is used, it is a keep alive, then all type of contents are supported by this particular web page is telling by our header lines. In the last part we can see that it is all about the data. So data and header line again separated by our carriage lines. So this is a response message, how it is working. So what are the another response code, what is used by our response message? So we already see 200, that is okay. So requested data is already successfully received by the receiver. That is all about the 200 OK. Sometimes you also see this type of message 404. When you are requested for some page and it is not available, then browser is telling about the 404. File is not founding. So that is the type of response which are generated by our server. So many other types of this type of status code is generated. It may be 301. Our file is permanently moved. 40, that means that request it is not accepted by particular server. Then 505, it is all about HTTP version is not supported. So this type of status code will be used by our HTTP system. Now we are moving to next two types that will be used by our HTTP protocol. That is all about the cookies. So how we are using the concept of cookies. So our websites are using the concept of cookies. It monitor how we are surfing, how our data will be saved. So cookies are mainly four components. One is cookie header line, that will be HTTP response message, then cookie header line in next HTTP request message, third cookie file. Cookie file will take about which user is doing this particular activity and what are the data will be saved, and the backend the database of the site. So when we are talking about the cookie, it monitors the particular user's activity and according to that it saves some information for future tasks. So this is the basic idea, basic of our cookies. So let's understand with the help of this animation. For example, we have a machine that wants to send the request. So here usually HTTP request message is given to this particular server. That is the customer ID of 1678 for the user. Now what happened? In the response it will generate this. So usually our HTTP response is set the cookie for 1678. So this is the conclusion. Cookies are generated by server, not the client, but it is saved at the client side. Purpose is very clear. If the same data requested is given by the user again, it will check by the server if the same specified resources are used by the client before this. If yes, if no updates are, then if no updates are available for the same page, then the server is giving the response for that particular ID. So cookie is just about to save the time during the surfing of our data over the network, but it maintained by the server. That pages are stored at the particular user side. For example, if you are searching any website and the heavily animated number of images are there, first time it will take more time. Second, the same website will be searched by you. It comes faster. How? Because when that type of website having heavy loaded, the images are there. So the first time when you are searching for that site, server is in the response, server is also sending that type of images. That is stored at the user side when the user accepting I am accepting the cookies. Second time when the user is requesting for the same website, that cookies value will be retrieved from your machine and only some information is gathered on the particular server. So this is the basic idea how our particular cookie is working. Now the last topic of today's particular application there is all about the proxy server. So how the proxy server is useful? So it satisfies the client request without involving original server. So in the last topic, we are trying to reduce the number of requested to go to the server. But using the proxy server, we are trying to move the particular request to the original side. So proxy, for that we are using the concept of proxy server. So let's understand this scenario with the help of this image. The number of client is there, number of server is there, that is original server. In between my proxy server is available. So user stage browser is web access. We are using the web access via cache memory. Browser sends HTTP request to our cache server. Okay, so object in the cache gets the return object from your cache memory, and else cache requested object from original server. So what happen here, if our data is not found in the cache memory, then it is our request is going to the particular original server. So this is the case how our particular task will be performed by the proxy server. So let's understand that if our data is generated by the particular server, if our data is not available at the proxy server first time, then what happen? Client request is on, then response is given, then that data is stored at the proxy server and the answer will be given to the client. So after step number 1, that step the data will be saved at which place? Proxy server. Now for the same data item, understand, client is requesting. So HTTP request, yes, response is generated by proxy server instead of our original server. So this is the case how the proxy server is useful to us. So this is the basic idea which will be already in the I understand and explain how it will be work. So cache act at the both the client and the server side. So server, that is for original one requesting the client, and client that is calling to the original server. So typically cache is installed by our ISP at our level, that will be provided by our university or company or any local ISP. So why the caching is useful here? Because it reduces the overall response time for a client, it reduces the traffic over the network, and it increases indirectly over internet speed here. So that's why we are using the concept of proxy server. So in this video, I explained in detail how the HTTP protocol and basic application layer protocol, basically how the application layer is working. So thank you for watching video.